During the day, he does marketing, and at night, he does star hopping. So that's Varun for you. Varun, it's all yours.
And it's probably born through our innate desire to know about the universe and ask and answer the big questions, which is where do we all come from? And where does this all lead to? Right? And if you look at it in a way, astronomy is the universe's way of understanding itself. And that is what differentiates us from other species. This innate curiosity and the thirst for knowledge that we have to understand the world around us. Can anybody tell me what this white band is? Anyone in the audience? Milky Way band. Perfect. Great. You guys are already more experienced than I am. So good to know. Since time immemorial, human beings have looked upon the night sky, gaze at it, and understand how everything works. Right? All these stars, all these clouds, this big white patch in the sky, all the galaxies, these tell a story which is billions of years in the making. And right now, if you go out at night in Bangalore, I bet you can't see more than 10, 15 stars, right? Can't see anything. It's too light polluted. But back in the day, there was no cars, there was no street lamps, there was nothing. And our ancestors had access to the most pristine skies the world has ever seen. So they were able to look back, look up, and see and trace the journey of these objects, these celestial objects, be it the stars, be it the planets, right? Year upon year, decade upon decade, they would capture, observe, and write down the movement of these celestial objects. Everything in the night sky, they would observe that it rises from the east and it sets in the west. Can anyone tell me why that is? Shall I repeat the question? When you look at the night sky, even the sun for that matter, it rises in the east and it sets in the west. And you'll notice a similar pattern whenever you look at the night objects, be it the moon, be it the stars, constellations, and whatever. Can anyone tell me why that is? Hands up, please, so I can just ask you guys once all. Anyone? Sorry? Earth's rotation, exactly. The Earth rotates from west to east, and that's why, relatively speaking, the night sky seems to move from east to west. Now, before I get into the details of astronomy, I wanted to show you one photo. This was taken by the Voyager 1 spacecraft on Valentine's Day in 1990. One of the, I think you should have it better. Right? One of the great astronomers of our times, Carl Sagan, he requested NASA to have the Voyager 1 turn around and take a shot of Earth. Do you see this dot? That's us. That's us from 6 billion kilometers. It's a mote of dust suspended in a moonbeam. Right? Everything that you know, all the wars, all sort of lectures, all workshops, the best filter coffee, everything is available only on this dot, as far as we know, right? And nowhere else. This is not exactly a great picture from technical point of view, right? It's very blurry. It's not very clear. You can barely make out the Earth here. But it shows the fragility of life and exactly where we are in the universe. It gives us a locus that this is all there is. And from this, we are now exploring the universe and trying to understand what it means. By the way, the Voyager 1 aircraft is now around, I believe, 14 billion miles away, 5 times farther than what it was when it took this photo. Right. So next, let me just give you a sense of where we are in the universe and attempt to explain the scale of this universe. Now, the numbers that we use when it comes to measuring distances in the universe are so huge that for the human mind, it is quite incomprehensible to understand this, right? But still, let us give it a shot. This is the solar system that we know of, right? Here is Earth. You can see the sun in the middle. This is not to scale. The solar system itself is so big that if I try to scale it here, it will probably extend from here to JP Nagar. Okay. But still, you get a sense, right? You have all the inner planets, you have the outer planets, you have the sun, and you get a sense of this solar system. But the solar system is just one of these systems in our galaxy, which is called the Milky Way. The sun is just a star, and our galaxy is known to contain anywhere between 100 billion to 400 billion stars. And so, this, of course, is the Milky Way, a photo that I took when I was outside the Milky Way, right? And this is approximately where we are in the outer spiral arm of our galaxy. Okay. But then Milky Way is not the only galaxy in this universe. This is something that we call the local group. So our galaxy, some of the dwarf galaxies that surround it, and then we have the Andromeda galaxy, which is our neighbor. And after 4.5–5 billion years, we are going to merge. But that's a topic for a different day. Right? The local group. So this particular grouping, the Milky Way galaxy and Andromeda galaxy and the surrounding dwarf galaxies, we call it our local group. Okay. This local group is again a part of the Virgo supercluster, as we call it, and again a very small part of that. The Virgo supercluster is again a part of something called the Lanakia supercluster, which is again a small part of that, and that is a small part of the observable universe. So just to give you a sense of where we are and how small we are when it comes to the size of the universe itself, it's really, really small. But still, we'll attempt to understand it to the best of our knowledge. Okay. Again, this is Astronomy 101. So we'll start with the very basics. And I'll not delve too deep into these topics because they are quite explanatory. But in case you have any questions at any time, please feel free to ask. Okay. In our solar system itself, we have what we call planets and moons, of course. Right? Planets primarily are into 4 different types. We have the inner planets, which we call the terrestrial planets. These are rocks composed of rocks and metals, which is basically Mercury, Earth, Venus, and Mars. We have the gas giants, right? Jupiter and Saturn. We have ice giants, which are Neptune and Uranus. These are earlier considered as gas giants, but upon reclassification, they have been reclassified as ice giants. And then we have dwarf planets. If you remember, we have now 8 planets, right? I think Pluto was bumped off the list in 2006. I, for one, was quite disappointed, but it is what the scientists say, right? Can't do much about it. That's, yes, exactly. The reason why it was started was as a protest, to protest against the ousting of Pluto. Right. Coming to the next structures in this universe. Nebulae, right? The word basically means cloud, and we have different kinds of nebulae. As and when we progress during the day, especially during the visual sessions and the astrophotography sessions, you will see much clearer, much beautiful images of these nebulae. By the way, these photos, they have been taken by BAS members themselves, right? So, yeah, there you go. I will not delve too deep into the different kinds of nebulae out there, but just for understanding, the primary way of classification is the way the lights are created. Either they emit light, or they reflect it, or they block light from somewhere else, right? Okay. Then we have planetary nebulae, which are basically a shell of gas from a dying star. This planetary nebula that you see, it's a ring nebula, but probably after 5 billion years, our sun will also end up into a planetary nebula. And after a few more years, it will end up into a white dwarf. Right? That is the evolution of our sun as well. We'll look at it later on. The important thing to understand is how stars are distributed in this universe, right? They are either individual stars, which is very rare, but usually they are part of some sort of a cluster or some sort of a galaxy. Now, there are 2 primary types of clusters of stars. They are called the globular cluster and the open cluster. Right? A globular cluster, if you look at it from a telescope, it will look like a very fuzzy sphere. It will have a very dense core, and it contains a lot of stars, from thousands to millions of stars. All right. Another important feature of a globular cluster is that it is full of old stars, and very, very old stars. The open clusters, on the other hand, is primarily made up of younger stars. There's usually no distinct shape, right? And usually contains far less stars. But the common thing that unites both of these are that these stars are gravitationally bound to each other. Okay. This is a very popular open cluster. It's called the heart cluster. And you can barely see the shape of a heart if you use your imagination, right? Okay. A lot of things that we astronomers look at in the night sky, you have to be deeply imaginative to understand the shapes that see. There's a cluster that looks like a starfish. I hope the AP folks have those images for you guys, right? There's a cluster that looks like an electric guitar. Okay, and we come up with these very interesting names. Astronomy as a science is always known for keeping very interesting names. The origin of the universe, Big Bang, right? Things we don't know, dark matter, dark energy, right? So that's how it is. It's a very simple science, and hope you guys will enjoy it as we go on along the day. The next big thing, of course, is galaxies. Primarily, there are three types of galaxies: elliptical, spiral, which is the Milky Way galaxy, and an irregular galaxy, right? So an elliptical galaxy will be a bit of an ellipsoidal shape or a spherical shape. It will have a dense core, right? And mostly it will have older stars. This particular photo is from the galaxy called M87. It is also known to have a very, very, very massive black hole inside it. You remember a few years ago, a photo of black hole came out by scientists, right? It's there, somewhere there. Then we have spiral galaxies. Now these galaxies have spiral arms. You can see these arms here, right? Okay. This is a very famous spiral galaxy. It's called the Whirlpool galaxy, right? There are active star-forming regions in these galaxies. So if you see these reddish pinkish dots, right? These are very active star-forming regions in the galaxy itself. And then what we have are irregular galaxies. They don't have any definite shape, right? They may have some star formation areas, and this particular one, as you see it, it's called the whale galaxy. You see the whale shape, if you use imagination, and this is the hockey stick, right? An inverted hockey stick. Okay. We'll not go into details about how galaxies are formed, as it is beyond the scope of this workshop. But in case you have any questions during the break, catch hold of any BAS member, they will be able to help you out with it. Okay. Now, again, one of the most important facts that we often miss out upon, that at the end of the day, we are all stardust. Whenever a star is formed, and there are different life cycles that a star can go. This particular one, the bottom third one, this is the path of our star, which is Sun, right? A protostar, the Sun forms, it goes into a red giant, a planetary nebula, and then a white dwarf. Okay, and then there are different kinds of other journeys that a star can take. A star is born, it lives its life, and it dies, just like us, right? And every single element that is present in a human body was once a part of a stellar nursery. That's where we came from. Right? Now, when you look up at the night sky, probably on a very good night and probably on the upper Himalayas or somewhere dark, you probably see stars like these, right? A very clear blinking stars. Back in the day, our ancestors, they would connect the dots and create a story out of it. So they connected the dots and they started seeing shapes in the night sky. And using those shapes, they started telling stories. so that wisdom and knowledge can be passed from generation to generation. This is a very famous constellation called Orion, and it's very prominently visible even from Bangalore, by the way. Right? Any Harry Potter fans here? Few of you? Yeah. So this star is called Bellatrix. This star is Sirius, right? So J.K. Rowling was also an amateur astronomer. We believe, we have not confirmed it yet. Okay. And there are very interesting stories around these characters, especially in Indian mythology, in Greek mythology, and so across the world. This belt of stars that you see, in astronomy, they have Arabic names. I think this is called the Alnitak. The second one, the middle one is called Alnilam, and this is called, Mintaka. But in Hindi, in Sanskrit actually, these are called Usha, Anirudh, and Chitralekha, the characters of Mahabharata. There's a very famous celestial dance, a celestial hunt that happens around Orion. You see this Taurus? Once you have the stellarium session, you will witness this, that this looks like a bull. Its two horns, his head here, there's a bull here. This is Orion is a hunter. You can see a basic human skeleton holding a bow and an axe, right, fighting the bull. And it is followed by his dog, Canis Major. Okay, right? One of the stories goes like Orion was bitten by a scorpion and that killed him. So Orion only rises in the night sky once Scorpion sets. Scorpion is another constellation. It's not here in this photo, but going forward, maybe somebody will show you that. So you'll notice and observe that once Scorpius sets, it's only then that Orion rises. And while this is a very important scientific fact, it was passed down from generation to generation from a simple story that the Orion can only come when the Scorpion is not there, right? So all these stories, they have some kernel of truth, and it would be very interesting to revise those stories, to go back to them and understand the truth that exists in them, and then correlate it with modern findings. The other thing is, when you saw these constellations, these stars are not usually in the same plane, right? These stars, as observed from Earth, they can be relatively spaced between them. But since we are seeing them from so far away, it looks like they form a particular shape. Can anyone identify this constellation? Can anyone identify this constellation? Saptarishi, right? It's a Saptarishi, exactly, Big Dipper. Okay. Again, there's a very good story about these two stars there, right? If there are any South Indian folks here, there's a story that goes as Arundhati and Vashisht, right? Married couples are made to look at these two binary stars and figure it out, right? Yeah. Almost to the end of my session, guys. Just bear for another 5 minutes. Back in 1995, do you know what this is? Anyone? Hubble telescope. Perfect. Spot on. You guys said you're all amateurs, no? How do you know all this? Something is going on here. Okay. Right. So the Hubble telescope, the folks at NASA, they decided to point it at one spot above the Saptarishi. Okay, at one spot. From Earth, this spot had nothing. We couldn't see anything there. And this spot is as big as a pinhead. If you hold a pinhead to the night sky, that's the space that it takes in the night sky. Okay. So it went here for 10 days, from I believe December 18th to 28th, 1995. It took 342 photos of this particular spot. Right? These photos were of long exposures from 15 minutes to 40 minutes each. And this was the result. Two questions here. Can anyone guess the number of stars in this photo? Anyone? 20,000? Right. So there are around 20 or so stars in this photo. Everything else that you see is a galaxy itself. There are, anyone can guess how many galaxies are there in this photo? Rough count, anyone? 3? Any guesses, guys? The one who guesses right gets 2 copies free. 100? How much? 10,000? What we know of, there are approximately 3,000 galaxies in this particular frame, in a patch of sky as big as a pinhead, right? This was the first idea that we had from the Hubble telescope, that how big the universe is. This particular image is called the Hubble Deep Field, and there have been multiple deep fields since then. It gives you a scale of how deep the universe is. The oldest galaxy in this particular one is around 12 billion light years from us. Light year, another concept. Anyone knows what a light year is? One person, please, hands up, and I'll ask them. Yes, please, ma'am. Exactly. So in 1 year, the distance that light travels is called a light year. What distance does the light travel in 1 second? Approximately 3 lakh kilometers, right? So imagine how far this is. And this is just one photo. And contrast this image, the detail of this image, with the first photo that we saw by Voyager 1. It's very blurry, right? And how far science has come in terms of understanding our place in this universe. The next thing I want to bring to your highlight is something called light pollution. And this is something that we struggle with a lot as astronomers. This is a video of how light pollution has increased in India in the last 7-8 years. You can see that there are still dark skies. The green parts are light areas, and if you see, by the time we reach 2023, things have become quite bad. This is the latest image. We don't have dark skies anymore in India, other than some spots in the Western Ghats, some areas in Rajasthan, and the upper Himalayas. That's it. And as we grow as a civilization, as we grow as a country, we will keep on losing these dark skies. So my request to you all is that whenever you get a chance, just look up. Know that you are part of a tradition that goes back 10,000 of years. Find your local astronomy club, find a dark sky, go out and see and observe the beauty of stars. All right? Thank you, guys. Have a good day.
Thank you very much, Varun, for that wonderful presentation. I have one request. I have two requests actually. Request you all to please turn off your phones or put it in silent, please. That is one thing. And especially in the back there, if you can maintain a little bit of silence, it will really help the people who are presenting here. Really appreciate that. So thank you once again, Varun. What you heard was an introduction to astronomy, as we both said.